The next inference procedure we're going to look at is the two-proportion z-test. The purpose of this is to test the null hypothesis that two population proportions are equal. Now, when we conduct a test of significance, we assume, for the sake of the work, that the null hypothesis is true. And if this is the case, then the null hypothesis implies that there is no difference in the populations with respect to whatever characteristic we're interested in. And then in that case, we can pool the samples together. So that gives us the pooled sample proportion, which is p hat, no subscript, and that's the sum of the number of successes in the two samples divided by the two sample sizes added together. Now we're going to use this p hat when we check conditions, and we're also going to use it when we generate our test statistic. Here are the conditions that apply to this test. We have to have two independent SRSs from two distinct populations. Each population must be at least 10 times its respective sample size. And then here's where that p hat comes in. N1 times p hat, N1 times 1 minus p hat, N2 times p hat, and N2 times 1 minus p hat all have to be greater than or equal to 10. The test statistic looks like this. We're assuming that the null hypothesis is true. Normally when you do a test of significance, you have a sample statistic minus some null hypothesis value. Well, the null hypothesis value of P1 minus P2 would be 0 in this case, so we don't have to subtract that off. And then down in the bottom, we've in effect factored out p hat times 1 minus p hat from both of these expressions here. And so we have p hat times 1 minus p hat over times the sum of 1 over n1 plus 1 over n2. And all that goes under a radical. If you do this on a calculator, you go to Stat Test 6, and you select two proportion z-test, number 6 off that list. Now here's an example of how this works. It's quite involved, and this is one of those procedures where you probably want to do as much as you can on the calculator, because the work is really lengthy, and if you get this on your AP exam, you're probably going to want to do as much as you can on the calculator, but you just have to deal with whatever you get. The example is, do Protestants and Catholics differ on whether free speech should include the right to make speeches in favor of communism? And these are the data that we have. We took a random sample of Protestants, of 267 Protestants, and 104 answered yes. That gives a sample proportion of 0.3895. We asked a random sample of 230 Catholics the same question, 175 said yes, for a sample proportion of 0.3261. The null hypothesis is that there is no difference between Catholics and Protestants on this issue, and the alternative is that there is a difference. The pooled sample proportion works out to be 0.3602. When we check our conditions, we have two independent random samples from each population. Each population is much larger than 10 times the respective sample size. And then for the third condition, we use p hat in checking all of these. They're all comfortably bigger than 10, so we can proceed. The formula for the test statistic, again, it's a z-statistic. P1 hat minus P2 hat over the square root of p hat times 1 minus p hat times 1 over n1 plus 1 over n2. We plug in all the values that we have for P1 hat, P2 hat, and p hat, and n1 and n2. A lot of substitutions, and then we simplify it down. It simplifies down to about 1.4676. When we calculate our p-value, this is a two-sided alternative, so we have to take 2 times the area in one tail, and that works out to be about 0.1422. That's a fairly large p-value. I would not reject the null hypothesis based on that. Apparently the difference that we're seeing is not rare enough to cause us to reject the null.